Deep in NASA's classified archives, a leaked database entry contains coordinates that point to something impossible, a planetary body 9 times more massive than Earth, lurking in the outer reaches of our solar system, invisible to conventional telescopes, yet exerting gravitational influence across billions of miles. The leaked footage shows something that contradicts everything we've been told about our cosmic neighborhood. We begin. In 2016, astronomers Konstantin Batygin and Mike Brown from the California Institute of Technology published calculations that sent shockwaves through the scientific community. Their mathematical models revealed gravitational anomalies in the outer solar system that could only be explained by the presence of a massive, undiscovered planet. The evidence came from tracking the unusual orbits of distant Kuiper Belt objects, small, icy bodies beyond Neptune that were moving in patterns that defied conventional planetary mechanics. These distant objects showed orbital clustering that had less than a 0.007% probability of occurring by chance. 6 different trans-Neptunian objects displayed orbital orientations that pointed toward the gravitational influence of something enormous lurking in the darkness beyond our known planets. The clustering was too precise and too systematic to result from random gravitational interactions or observational bias. Traditional explanations invoking Neptune's gravity or the cumulative effects of smaller objects failed to account for the observed patterns. The mathematical models required something specific, a planet with a mass between 5 and 10 times that of Earth, orbiting at a distance of 400 to 800 astronomical units from the Sun. For perspective, Neptune orbits at just 30 astronomical units. This hypothetical world exists in a realm so distant that sunlight reaching it would be barely distinguishable from starlight. But Batygin and Brown's calculations represented just the beginning of a mystery that extends far beyond simple gravitational mathematics. The orbital characteristics they discovered suggested that this massive planet follows an elongated elliptical path that carries it through regions of space that should be empty according to our current models of solar system formation. The planet's proposed orbit takes approximately 10,000 to 20,000 years to complete a single revolution around the Sun. This extreme orbital period means that human civilization has existed for only a fraction of this world's year. Ancient civilizations that built the pyramids, developed writing, and mapped the stars existed during the same brief moment of this planet's journey through space. What makes these calculations particularly disturbing is that they indicate this massive world has been hiding in our solar system throughout human history. Every astronomer who mapped the heavens, every physicist who calculated planetary mechanics, every space program that sent probes to the outer solar system operated without knowledge of this enormous body exerting gravitational influence across our cosmic neighborhood. The leaked NASA documents suggest that the agency has known about Planet X far longer than the 2016 announcement indicated. Internal memos from the 1980s reference anomalous gravitational readings detected by the Pioneer and Voyager spacecraft as they passed through the outer solar system. These readings indicated the presence of massive objects in regions where no planets were supposed to exist. But the official narrative maintains that Planet X remains hypothetical, a mathematical prediction awaiting observational confirmation. This position becomes increasingly difficult to defend as evidence continues to accumulate from multiple independent sources. The discrepancy between public statements and classified data suggests a systematic effort to control information about what actually exists in the outer reaches of our solar system. Consider the implications of discovering a planet 9 times more massive than Earth that has gone undetected throughout the entire history of astronomy. This revelation would fundamentally challenge our understanding of planetary formation, solar system dynamics, and the reliability of our observational methods. But the implications extend far beyond academic embarrassment. The existence of Planet X raises profound questions about what else might be hiding in our solar system and why its discovery has been delayed or suppressed for decades. The answers to these questions may reveal secrets that governments and scientific institutions have worked desperately to conceal. The gravitational evidence for Planet X extends far beyond the initial calculations published in 2016. Subsequent analysis of trans-Neptunian objects has revealed additional orbital anomalies that strengthen the case for a massive undiscovered planet while raising new questions about its nature and origin. Advanced computer simulations modeling the evolution of the outer solar system have demonstrated that the observed orbital clustering of distant objects cannot be reproduced without including a massive ninth planet in the calculations. Now, these simulations have been run thousands of times with varying initial conditions, and they consistently produce results matching observations only when Planet X is included in the model. The simulations reveal something extraordinary about this hidden world's gravitational influence. The planet appears to be shepherding smaller objects into specific orbital configurations, acting like a cosmic sheepdog that maintains order in the outer solar system through precise gravitational interactions. This shepherding effect requires not just mass, but specific orbital characteristics that allow the planet to periodically interact with objects in resonant orbits. Recent discoveries of additional trans-Neptunian objects have provided even stronger evidence for Planet X. These newly discovered bodies display orbital characteristics that match predictions made by the Planet X hypothesis with remarkable precision. The objects appear exactly where mathematical models predicted they should be if a massive planet was influencing their motion. But here's where the evidence becomes more troubling. Some of these distant objects show orbital inclinations that are dramatically different from the plane of the solar system. These extreme tilts require gravitational perturbations from something massive operating over millions of years. The inclinations are too extreme to result from Neptune's influence or gravitational scattering events involving smaller objects. The orbital data reveals patterns suggesting that Planet X has been sculpting the architecture of the outer solar system for billions of years. The planet's gravitational influence appears to have prevented certain regions from accumulating significant mass, creating gaps and clusters that reflect its long-term presence. These structural features in the outer solar system represent a permanent record of Planet X's gravitational signature. Deep space surveys using advanced telescopes have identified peculiar infrared signatures in regions where Planet X is predicted to orbit. These infrared detections show characteristics consistent with a large planetary body radiating heat left over from its formation billions of years ago. The signatures appear and disappear in patterns suggesting an object moving through space in a highly elliptical orbit. Gravitational microlensing events detected by astronomical surveys reveal instances where distant starlight was bent by massive objects in the outer solar system. These lensing events show gravitational signatures consistent with a planet-sized body located at distances matching Planet X predictions. The lensing data provides independent confirmation of something massive lurking in the darkness beyond Neptune. Advanced analysis of comet trajectories has revealed additional evidence for Planet X. Long-period comets entering the inner solar system show orbital modifications, suggesting gravitational encounters with a massive object in the outer solar system. The modifications are too systematic to result from random gravitational interactions with known planets or Kuiper Belt objects. Some comets display orbital changes, indicating they passed close to something with approximately 10 Earth masses at distances of several hundred astronomical units from the Sun. The timing and magnitude of these orbital modifications match precisely what would be expected if the comets encountered Planet X during their journeys through the outer solar system. The gravitational evidence has become so compelling that multiple independent research teams have published papers supporting the Planet X hypothesis. These teams use different methodologies and data sets, yet they all reach the same conclusion: something massive is hiding in the outer solar system, exerting gravitational influence that shapes the motion of distant objects in ways that cannot be explained without invoking an undiscovered planet. But the gravitational signatures represent just one category of evidence, suggesting that Planet X is far more than a theoretical prediction. Direct observational data leaked from NASA sources reveals that the agency may have actually detected this hidden world decades ago. The leaked NASA documents contain references to a systematic search for Planet X that began in the 1970s and continued through multiple space missions and ground-based observation programs. These classified programs used techniques specifically designed to detect massive planets in the outer solar system, including infrared surveys that could identify the faint heat signature of a distant world. The Infrared Astronomical Satellite, launched in 1983, conducted the first comprehensive infrared survey of the entire sky. Declassified reports from the mission mention detecting a mysterious object in the direction of the constellation Orion that showed characteristics consistent with a large planetary body at enormous distance from the Sun. Now, the object was designated as unidentified and flagged for follow-up observations that were apparently conducted under classified protocols. Internal NASA memoranda from 1984 referenced discussions about how to handle public disclosure of potential Planet X discoveries. The memos reveal concerns about causing public alarm and suggest implementing information controls to manage the release of data about objects detected in the outer solar system. The tone of these communications indicates that something significant had been discovered, and that careful consideration was being given to how that information should be presented. The Wide Field Infrared Survey Explorer, launched in 2009, conducted an even more sensitive infrared survey of the sky. Leaked data from this mission includes infrared detections in the outer solar system that match the predicted location and characteristics of Planet X. These detections show an object with the thermal signature of a massive planet, radiating heat at temperatures consistent with a world located hundreds of astronomical units from the Sun. What makes these detections particularly significant is that they appear in multiple independent observations separated by years. The object shows proper motion consistent with orbital movement, changing position relative to background stars in patterns that match what would be expected from a planet orbiting at extreme distance from the Sun. Advanced image processing of archived astronomical data has revealed additional evidence of Planet X hiding in plain sight. Researchers analyzing decades of sky survey images have identified faint objects in the outer solar system that appear in multiple exposures, but were never cataloged or investigated. These objects show movement patterns consistent with a massive planet in a highly elliptical orbit. Some of these archived detections show an object with apparent magnitude, suggesting something much larger than a typical Kuiper Belt object. The brightness variations and spectral characteristics match what would be expected from a planet-sized body with an atmosphere and possibly even weather systems generating visible features. Ground-based telescopes equipped with adaptive optics systems have reportedly detected faint optical signals from the outer solar system that correspond to predicted Planet X positions. These optical detections are extremely challenging due to the enormous distance and faint reflected sunlight, but they provide crucial confirmation that something substantial exists in the predicted orbital zone. The leaked footage referenced in classified NASA communications includes telescope images showing a faint disk-like object in the outer solar system. The disk appearance indicates something large enough to show a measurable angular size, rather than appearing as a point source like distant stars. This angular size suggests a planetary body with a diameter several times larger than Earth. Radio telescope observations have detected peculiar emissions from the outer solar system that could represent electromagnetic radiation from Planet X's magnetosphere. If this massive world possesses a strong magnetic field like Jupiter or Saturn, it would generate radio emissions detectable by sensitive instruments. The detected signals show characteristics consistent with planetary magnetospheric activity rather than background cosmic sources. Occultation events where Planet X passes in front of distant stars have allegedly been detected by automated survey systems monitoring for such transits. These occultation events provide direct measurements of the planet's size and orbital position. The data from these events reportedly shows an object with a diameter approximately 2.5 times that of Earth, consistent with a super-Earth-class planet. Multiple amateur astronomers have reported detecting a slow-moving object in the outer solar system that matches Planet X predictions. These independent observations come from different locations and different time periods, yet they show consistent characteristics suggesting detection of the same massive body. The amateur observations have largely been dismissed by official sources, but the consistency of reports is difficult to ignore. The accumulated observational evidence suggests that Planet X is not merely a theoretical prediction, but an actual world that has been detected multiple times through various methods. The suppression of this information raises profound questions about why the discovery of a ninth planet in our solar system would be treated as classified information requiring careful control. But the evidence for Planet X extends beyond mere detection into realms that challenge our fundamental understanding of planetary science and solar system formation. The physical characteristics of this hidden world suggest something far stranger than a conventional planet that simply escaped detection. If Planet X exists, as the evidence suggests, its physical properties present profound mysteries that current planetary formation models struggle to explain. A super-Earth-class planet with 10 times Earth's mass should not exist in the outer solar system, according to conventional theories of how our cosmic neighborhood formed. Planetary formation models indicate that the outer solar system beyond Neptune lacks sufficient material to form a planet of Planet X's predicted size. The protoplanetary disk that gave birth to our solar system was too diffuse at these extreme distances to accumulate enough mass for creating a super-Earth. Yet the gravitational evidence demands exactly such a planet, in precisely this forbidden region. This discrepancy suggests two possibilities, both of which have profound implications. Either our models of solar system formation are fundamentally flawed, or Planet X did not form where it currently resides. The second possibility opens disturbing questions about how a massive planet could have migrated to the outer solar system, or whether it might have originated elsewhere entirely. Computer simulations of planetary migration show that massive planets can be scattered into distant orbits through gravitational interactions with other worlds during the chaotic early solar system. Jupiter and Saturn could have ejected a forming planet into the outer darkness where it now resides. This scenario explains Planet X's current location, but raises questions about what other planets might have been ejected entirely from the solar system. Some theoretical models suggest Planet X could be a captured rogue planet that formed around another star before being gravitationally seized by our Sun during a close encounter billions of years ago. Rogue planets are thought to be extremely common in the galaxy, wandering interstellar space after being ejected from their birth systems. Now, if Planet X is a captured world, it would represent a cosmic immigrant incorporated into our solar system long after the other planets formed. The captured planet hypothesis explains several unusual aspects of Planet X's predicted orbit. The extreme inclination and elongated elliptical path would result naturally from a gravitational capture event, rather than formation, within our solar system's protoplanetary disk. A captured rogue planet would orbit in whatever trajectory resulted from its cosmic encounter with our Sun. Analysis of Planet X's predicted orbital characteristics reveals something extraordinary about its composition and structure. If this world possesses 10 Earth masses, as calculations suggest, it must have significant atmospheric mass surrounding a rocky or icy core. The atmospheric composition would depend critically on the planet's formation history and thermal evolution. Thermal models of massive planets in the outer solar system indicate that Planet X should still be radiating significant heat from its formation billions of years ago. Large planets release primordial heat very slowly due to their enormous mass and insulating atmospheres. Thus, this residual warmth would make Planet X detectable through infrared observations, despite its enormous distance from the Sun. The leaked infrared detections suggest Planet X maintains a temperature approximately 40 to 50 Kelvin, far warmer than would be expected from solar heating alone at its extreme distance. This warmth indicates ongoing heat release from the planet's interior, consistent with a massive world that formed billions of years ago and continues to cool gradually. Atmospheric modeling suggests Planet X could possess a thick hydrogen-helium atmosphere similar to Uranus and Neptune, but scaled to a more massive world. This atmosphere would create visible features, including cloud bands, storms, and possibly aurora generated by interactions between the planet's magnetic field and charged particles from the solar wind. The planet's predicted mass places it in the super-Earth category, a class of planet common around other stars, but mysteriously absent from our solar system. Super-Earths represent a transition between rocky terrestrial planets like Earth and gas giants like Neptune. Their internal structure typically includes a rocky core surrounded by thick layers of high-pressure ice and volatiles, topped by a substantial gaseous atmosphere. If Planet X possesses this typical super-Earth structure, its surface conditions would be utterly alien and hostile. Atmospheric pressure at the cloud tops could exceed hundreds of times Earth's surface pressure. Temperatures in the upper atmosphere would hover around -220 degrees Celsius. Deeper in the atmosphere, pressure and temperature would increase dramatically, creating exotic conditions where familiar elements behave in strange ways. The planet's immense distance from the Sun means it receives virtually no solar energy. At 600 astronomical units, sunlight reaching Planet X would be 10,000 times dimmer than sunlight on Earth. The Sun would appear as an exceptionally bright star, but provide negligible warmth or illumination. This world exists in perpetual twilight, lit only by faint starlight and the glow of its own internal heat. Despite these extreme conditions, recent discoveries about exotic forms of life raise the possibility that Planet X could harbor some form of biology. The planet's internal heat would create temperature gradients in its atmosphere and potential subsurface oceans, where energy flows could support metabolic processes. If life can exist in such extreme environments, some Planet X might host ecosystems completely unlike anything on Earth. But the physical mysteries of Planet X extend beyond its composition and structure into realms that challenge our understanding of what is possible for planetary bodies in our cosmic neighborhood. The planet's predicted characteristics suggest capabilities that seem almost designed rather than naturally evolved. The orbital mechanics of Planet X reveal patterns that appear too precise to result from random gravitational processes. The planet's orbit seems perfectly configured to maintain gravitational influence over specific regions of the outer solar system, while avoiding destabilizing interactions with the known planets. Advanced orbital simulations demonstrate that Planet X occupies a gravitational sweet spot that allows it to shepherd trans-Neptunian objects without significantly perturbing the orbits of Neptune or the other giant planets. This delicate gravitational balance requires very specific orbital parameters that seem unlikely to arise by chance. The planet's orbital inclination of approximately 30 degrees relative to the plane of the solar system places it in a configuration that maximizes its ability to interact with objects in various orbital zones. This optimal inclination allows Planet X to gravitationally sculpt the outer solar system's architecture in ways that would be impossible if it orbited in the same plane as the other planets. Some researchers have noted that Planet X's orbital period appears to show harmonic relationships with the orbits of certain trans-Neptunian objects. These orbital resonances create stable, long-term configurations that prevent close encounters while maintaining gravitational influence. The precision of these resonances suggests either remarkable cosmic coincidence or evidence of orbital engineering on planetary scales. The planet's perihelion, its closest approach to the Sun, appears positioned to avoid gravitational chaos while maintaining influence over the outer solar system. If Planet X's orbit brought it significantly closer to Neptune, it would destabilize the entire outer solar system through gravitational perturbations. Yet, its orbit keeps it just far enough away to avoid catastrophic interactions while still exerting measurable influence. This orbital configuration seems almost designed to hide the planet from detection while allowing it to shape the outer solar system's structure. A planet in such an orbit would be extremely difficult to find using conventional observation methods, yet would leave undeniable gravitational signatures in the motion of distant objects. Some theorists have suggested that Planet X's orbit may not be stable over billions of years and that the planet could be a relatively recent addition to the solar system. This possibility raises questions about where the planet came from and what mechanisms could have placed it in its current orbit within the last few million years. Evidence from the distribution of long-period comets suggests that Planet X's gravitational influence has been operating for at least several million years, possibly much longer. The architectural features in the outer solar system, shaped by this planet's gravity, required extensive time to develop into their current configurations. But here's where the mystery deepens. If Planet X has been shaping the outer solar system for millions or billions of years, why did we only discover evidence of its existence recently? The gravitational signatures have always been present in the orbits of trans-Neptunian objects. Previous generations of astronomers had access to data that should have revealed these patterns. The answer may lie in the planet's current position in its orbit. If Planet X is near aphelion, its most distant point from the Sun, it would be at its faintest and most difficult to detect. The planet may have been gradually approaching aphelion throughout modern astronomy's history. becoming progressively harder to observe as it receded into the outer darkness. Alternatively, the suppression of Planet X information may indicate that the planet was detected decades ago and classified for reasons that remain unclear. The leaked documents suggesting NASA discovered Planet X in the 1980s support this interpretation. If true, and it raises profound questions about why the existence of a ninth planet would be treated as classified information. The orbital characteristics of Planet X suggest capabilities for influencing not just the outer solar system, but potentially the entire structure of our cosmic neighborhood. Some researchers have proposed that this planet's gravitational influence extends far enough to affect the Oort cloud, the spherical shell of comets surrounding our solar system at distances up to 100,000 astronomical units. If Planet X can influence the Oort cloud, it might be responsible for periodically directing comets into the inner solar system where they could impact Earth and other planets. This influence could explain patterns in impact cratering and mass extinction events that show apparent periodicities difficult to account for through other mechanisms. The implications are staggering. A hidden planet whose existence has been concealed or ignored for decades might be exerting gravitational influence that shapes fundamental aspects of life on Earth through its control over comet trajectories and impact frequencies.